Okay, so we're going to look at our universal first. That's this one right here with the two long and angular shafts here. So what is the angular range of motion for the universal joint? It's about 45 degrees. If I turn this, it'll be, you can kind of see, so right now we're at 0. We can crank this up, it'll go up to about 45 degrees and anywhere in between. If you loosen this, it probably would go a little bit more. For our sake, we're going to say it's 45 degrees. Is the speed increased, decreased, or constant as I'm rotating these in here? Or using the angular part? The speed stays the same. These turn together, they rotate together. So our speed is constant. Again, if speed is constant, torque is constant. It takes no less power to move either of these. But notice I do have to use our front axle to rotate or move the back one. So we have our input in the front and our output in the back. We have, what is the speed ratio? So if these are moving at the same speed, wouldn't the speed ratio just be 1 to 1? So just like a gear ratio, since there's no gears on this, they're just asking about speed. So if I move or rotate this piece, it's moving or rotating the output at the same speed. So we're going to write our speed ratio the same as a gear ratio of 1 to 1. Is the flow of power reversible? Can you make the input shaft turn by turning the output shaft? So I can make them turn. I'm turning this output shaft and it's turning the input, but I can't do the angular piece. A little different. There's kind of a joint in here. It's like your elbow. Okay? So I can turn these, but it kind of bends like your elbow does in the middle here. Up to that 45-degree angle. Do the input and output turn in the same direction? Yes. Again, just like they're reversible, they turn together. They're locked in here in the middle, just like your elbow. So if I rotate, everything turns in one direction. And an example where you might see this, they're in gondolas, like a ski lift. There could be in a lot of rolling machines. Again, you get a little bit of an angle, and then they can rotate together. So you have something at its side spinning, it may have a universal joint in there. And also in the drive shafts for a lot of cars. Again, that angular motion really lets us do what we want. But then spinning the same direction, allowing to drive in forward or reverse. So gondolas, rolling machines, or drive shafts. For our chain drive, we have our drive. We're going to have the larger gear, because it has the crank on it, remember, that's what we're putting all our power into, the input. And our output, or the driven gear, is the smaller gear. And these are a little bit different than the gears with teeth. These are actually called sprockets. So we have our drive sprocket and our driven sprocket. Is the speed increased, decreased, or constant? Oh, if I'm spinning my drive sprocket, it's larger than the small sprocket, so speed increases. The small one will spin around faster than the top one. And our torque, then the same, it would be decreased. We're getting a little less power out of our driven sprocket because it is smaller and it is spinning faster. So our torque is going to be decreased while our speed is increased. The gear ratio, similar to with regular gears. For our sprocket, since this one is bigger and it spins faster, we're going to say it's 2 to 1. Knowing that, okay, this output gear spins around about twice as fast as the large gear, the large sprocket. Or 2 rotations of our small one equal 1 of our big input gear. So 2 to 1. So what if we were to switch which one is the drive gear? So now I put my crank on the small sprocket and I spin that. Now that becomes our drive gear because we're putting all our power into that. That would cause speed, torque, and the gear ratio to switch, basically, you know. So this would actually be 1 to 2 would be the gear ratio. Speed would decrease now that we're going from a small to a large sprocket, and torque would increase because we're going from a small to a large sprocket. So everything would just flip-flop to what it normally was. And do the input and output shafts turn in the same direction? So here's a large difference for the chain drive. Notice we have 2 gears here, not 3 like in the simple gear train with idler, but 2. So in our gear train A and B, the 2 gears together, we're spinning the opposite direction. But in ours, these are spinning the same. That's because this chain, which is moving in a large circular motion, they spin in the same direction. An example where you might see this is, again, in the bike. This is exactly what you're going to see in a bike. You have a bike chain, you have a large and a small sprocket, and then if you have a bike that switches gears, you just have different size gears lined up that this chain will flip-flop out of, whatever you pick. So you would see this exactly on a bike. And an advantage of using a chain sprocket over a belt drive, so the belt drive is kind of rubbery, it's slippery, it's not locked on, there's not really teeth on it like a sprocket has. So there's less slip in a chain drive, get a little more power out of it, and durability. And that's all we have for the universal and chain drive.